So for those of you who have not had to go through all this in great detail in classes or whatever, there are the layers. We have to sort of take a moment to talk about the layers of networking. Physical layer at the bottom, if you can see it, that's just RJ45 cables, basically. The next layer is called data link. That's the LAN, basically. That's still Ethernet at that level. And then you can get out to the wider area network, which is called the networking layer. That's where IP comes in. Now, we often hear the word TCP/IP, thinking that it means all the same thing, but it doesn't. The next layer up above that is called the transport layer. That's where the TCP comes in. The Internet uses that TCP/IP, Transport Control Protocol, transmission control protocol with IP, Internet Protocol. That transmission control protocol is the thing that makes the Internet as robust as it is, because it basically allows data rate to flow based on what's available in the network, and if there's missed packets, it replaces them. Now, that's where you get most of your latency, however, and so in the AOIP world, we are saying we're just using LANs, we're using multicast, and we're not using TCP because we don't want that. We don't need that for the latency it gives us. We don't need it anyway because we're not running into these bandwidth clogging issues. We're not running into lost packets because it just doesn't happen in a LAN. So we use UDP, another form of transport layer, the Uniform Datagram Protocol, and this has much lower latency, but it also has no way of recovering lost packets. Well, that's just perfect for this application only. And in fact, most internet streaming, internet radio, actually uses UDP. But by and large, most of the other internet traffic, your typical data traffic, uses TCP. So that's we're sort of picking and choosing from this really nice set of standards that are out there, and finding the ones that work just for this very specialized application. On top of that, there's another, at the application layer, as the Internet calls it, we use something called real-time transmission protocol, which optimizes the packets for streaming. Remember, the Internet was not envisioning streaming when it was first built. This was kind of something that was thrown on at the end. Remember, real audio and all that in the very beginning. And so this is, RTP was formed at that time, and now it's pretty much the standard top layer used for streaming audio. So we use RTP in the audio over IP world as well. And then on top of that is where you get the proprietary manufacturer-specific implementations above that, if you're using AOIP. So that's the stack there. Now, for those who have actually studied this, you'll remember there used to be this old 7-layer dip here, the 7-layer model of the so-called OSI reference model, which has, these are really the 7 layers of networking. In practical application, the Internet took that down to 4. Primarily by squeezing the bottom 2 and the top 3 together, because you really didn't need all this, as it turned out. This came back from the 60s, the OSI. In the 80s, the Internet put together this much more simplified kind of layering, where you have basically a physical link layer, and then you have the IP, then you have the TCP or the UDP or other transport layers, and then you have the specific application, which can be anything, and that's where we put RTP. And in the AOIP, we sort of take a look at this, and it's slightly hybridized in the sense that we split up the network, we split back up the network in the data link model layer, because it really is where the logical and the physical networks separate. This is the hardware versus the software, basically, of the system. As one colleague likes to say, signal to noise is physics, everything else is math. And so this sort of happens that way, kind of like that here. Physical layer, and notice that in the standards, The IEEE, it writes the specs for Ethernet, basically. That's this. And then above that, it's IETF's domain, where they do all the sort of cool math and fun and games with just basically data, software. So that's really the layer as we're dealing with them for those of you keeping score. Now here's the packet we talked about. You see the headers for the various layers that we've talked about. So this is where the layers really, this is where the rubber hits the road for the layer. These packets, these are the things that are actually flowing around the network. That's where your audio is going in the middle there. That's got a little RTP header on it. That's a special sauce for real-time streaming media of any kind, but audio among them. And then you have the UDP header, which gives you a fairly lightweight amount of data because, again, we're not trying to recover packets here. We're not trying to throttle bandwidth with it. It's just basically an address. And then it moves forward with pretty much anything inside it. The IP header has all that address spacing for the internet level, but most of the work in these AOIP systems in terms of routing happens in this Ethernet header. So that's the map of the packet itself. So what happens in this AOIP routing? Well, we'll call the layers by their number from this point forward. Layer 2 is Ethernet, let's say. Layer 3 is IP. Layer 2 and 3 are the ones, remember, where we cross the boundary between physical and logical. Layer 2 is the top of the physical network. Layer 3 is the bottom of the logical network. So layer 3 is IP, layer 2 is Ethernet. You can do your routing in an AOIP system in either case. Typically, though, you use layer 2 because it's simpler, cheaper, and generally enough for most facilities. But if you ever needed to turbocharge the system and really talk to a huge facility, then you could always move up to layer 3 at your core and put an IP router rather than an Ethernet router there. So that's Ethernet versus IP. They both are possible to use in these standardized systems. As we said, AOIP almost always uses multicast, multicast Ethernet, as well as multicast IP. That helps you to be able to have, like I said, this point-to-multipoint routing in both layers. And then this is the systems that we're familiar with mostly use this IGMP as the standard management protocol, another IETF standard that allows very simple, and again, this thing is very powerful. What we're using it for is pretty minimal, just scratching the surface of its capabilities to use as a control for the routing. And this is done in hardware or in software, a PC that allows you to set your cross points on a cartoon router that looks like cross points, but it's actually just packets being switched around. So we can think about it the way we're used to saying this input goes to these 3 outputs and so forth. And you can see it visually on a screen. Or you literally just dial it up on a piece of hardware, and that's what these manufacturers build specially. But what's under the hood is just all the standard IP-based stuff. There's really nothing inside these consoles, pretty much, because they're all talking to an engine elsewhere. It's just a control surface, and it could just as well be a PC. But broadcasters like to touch faders and push buttons, to make it feel like it's real radio. So, and see meters moving and so forth. So it's just a matter of the human interface that is either hardware or software, your choice.